So this is related rates again. Yes. All we're going to do today is examples again. So here we go, example 1. It says a tank of water. Please put a star beside this one. The tank of water in the shape of a cone is leaking at a constant rate of 2 meters cubed per hour. If the radius of the tank is 5 meters and the height is 14 meters, A. At what rate is the depth of the water changing when the depth is 6 feet? Sorry, 6 meters. B. At what rate is the radius changing? When the depth of the water is 6 meters. All right, this is a fantastic question. Okay, meaning that you will see something like this on your test and your choice designer, okay, because this is fabulous. Okay. Now, the reason this is a difficult question is that there's no diagram, nothing is given to you at all. All right. What you'll have to do is make up everything from scratch. That's what makes this difficult. Once you guys get the equation set up, this is an easy question, but the hard part is the setup.
What's the equation for volume?
Good question. 1/3 pi r squared h. I'd give you that. I would give you that if you need to. Okay. I'm not going to ask if you need to. All right, so here we go. I'm going to start with Tyler here. Sorry, go ahead. Yeah. Oh, all right, on board. It's V equals 1/3 pi r squared h. All right. So let's start with part A. I'm going to draw a diagram, all right, which may not be helpful. Okay, so here's going to be my cylinder. Go with me here. That's a cylinder from the side. Cone, yes, obviously. Obviously. Okay, so that's a scenario with something like that. Okay. All right. I'm going to give you a second to scribble that diagram down, and Tyler's going to give me a piece of a piece of information that I can know from this. If your diagram's not as good as mine, that's fine. Okay. I majored in art in university, yes, and I was from Jason. Okay, I didn't in mine. I did not major in art. I majored in computer science. All right, Tyler, is there anything that we know about this question? Okay, so what's that going to be then? If it's going to be leaking. So what's that? What's changing there? I'm going to call this dV instead. Your volume is going to be dropped, right? If it's leaking, right? If it's leaking, you're going to have less volume, right? So I'm going to call dV by dt equals -2. What else do I know? Amelie, what else do I know, please? I can't help it's my daughter. It's her fault. She's 4 years old. That's what she calls you every day. And she thought you taught her 3 weeks in a row.
No.
I know, it's just once. Go ahead. What else do we know about this? Anything? Look at part A first of all. So I think we're done with the given part. Let's look at part A. What do we know for part A in this case? Yeah, good. So then what's the depth going to be? H, thank you. Okay, so H is going to be 6. Good. All right. Jeff, what else do I know for part A? We'll get to that maybe in one sec. But what am I actually looking for, Jeff, in this case for part A? Rate of change in the depth of the water. We're trying to call it dH by dt. Okay, yeah, R is 5 at the top. Now here's the thing you guys got to be aware of here. Okay, the problem is R does not exist anywhere inside this question. You take a look, right? I see R nowhere inside this question. Can somebody give me an idea of how I might be able to eliminate R from my question? So I'm going to need it. How would you write R in terms of H? Oh, goodness. Sorry? You could use trig. Maybe not. Yeah, go ahead. Sorry? Yeah, okay. We could call R is going to be, well, not... Well, let's redraw this triangle here for 1 sec here, okay? So what do we know about this little triangle? That's going to be my radius, which I don't want to put in there. Okay, I don't want that radius, okay? What can I use instead then? What's the height going to be then? It's going to be 6. Okay. Yes. Well, sort of. I'm not going to really do that. I'm going to use similar triangles that I think might be useful here for one sec. Okay. Why am I allowed to use similar triangles here? Because they're the same here. Okay. So I can actually use that, and this is where the sort of the aha magic moment is. That's why I want to show you these. So in case you ever do this again, you can do it. Michael, since you're up, how would I solve for R in this case? R equals 514H. Oh, I wasn't even going there. But yes, I was going to say something like R over 6 is 5 over 14. That's what I was going to say. No, is this what that we're good? Yeah. Okay. So R is 30 over 14, which is 15 over 7. Now, the reason that I did that was because nowhere does it mention in there dr by dt. Okay? So the thing is, because there's no dr by dt, I want to sort of eliminate it from the question. Right? All right, so as mentioned here above here, I'm going to say the volume is 1/3 pi r squared h. Okay, so I'm going to call that volume equals 1/3 pi 15 over 7 squared h. right, Evan, can you take the derivative of that, please, for me? It will be once we take the derivative of it. The only thing you had to use the h for was this part here, right? Okay, we need to take the derivative of that because we need dh by dt. No, that would just give you the volume. That's what it would do. Well, do you want to do that? We can try that way. We can see if we get the same answer. Okay, so Evan's got a problem. That's okay, I have a problem with that. So what he says instead, he wants to put in here, and this is a fair thing, so he wants to put h in there as well instead of that. All right, so what he would do then, I'll do this one here. Okay, so he says that r over h is 5 over 14.
So we're going to be solving for dv over dt.
So r, I'm gonna say r is going to be 5h over 14. Right? So then v is going to be 1/3 pi 5h over 14 squared times h. So v is going to be 1/3 pi of what? 25h cubed over 196. And this will probably, hopefully work too to get the same thing. Is that what you're talking about, I think? Evan, is that? Hopefully. You just want to make it easier to find the volume, okay?
I'm doing something like that.
Well, because the dr by dt, we have no relation to it. These are two unknowns then. Okay, the problem was, and I'm happy with this, let's forget about that one, keep this one. Okay. The problem was over here, we know what, we're looking for dh by dt. Thing is, you can't have two unknowns. If dr by dt and dh by dt would be unknown. Right? Okay, so because of that, you can't have two unknowns in the question. Right? So then what I just do, actually I like Evan's way better than my solution here. Now if you take a look, I only have two variables as v and h. Okay, so since I have v and h, then I can, I'll have a dv by dt and a dh by dt.
But the other way, you mean v and h too.
I know. We'll hopefully still get the same answer. Okay, so both these, we'll try them both out. Hopefully they both work to be the same. That's my dream anyway.
Break up the record.
Well, we'll try both. All right, Charlena, using your wonderful calculus skills, can you take the derivative of this, please? Go ahead. The derivative. Is that right? Yeah. 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 Go with that way then, okay? So the derivative of 20, I'm going to leave that as a constant outside. What's the derivative of h cubed going to be? Almost. Yeah, okay. So what we did here was, right, I just took out the constant 25 over 196. All right, Rebecca, is there anything I can do now? Somebody help her. What else can I put in here now? Yeah, go ahead. Okay. And I think I can use 6 for h here. Okay. Now, 3 and 3 will cancel, so I can probably get rid of those. Okay. 6 squared is 36. Oh boy. What's 36 times 25? I can't do that. 900. Someone just confirm that for me, because that was done in my head. That's wrong. Wrong. Is that right? I think that's right. That's good? And I'm sure lowest terms and all that stuff, right? What's that? Right, we're looking for the rate of change, though. That's what we're looking for. It's like the change in height for, you know what I mean? So then dh by dt I'm having as negative 392 over 900 pi. I'm sure that can be gone below me that in a decimal and we'll see if we get the same answer as I have here. This is my answer, negatives. That's what this answer on the right of the left one is. Oh, because you're dividing, right? You know what I'm saying? Like you're dividing. I hope that's right. Is that right? Because then 900 pi is in the denominator, right? Yeah. Because what the differentiation is, right? You're relating two variables, taking a derivative of something related to something else, right? So the idea is you're relating both of these to time. So it's the change, sorry? It's just this change of each one compared to time, that's all it is. So that's the difference. You have multiple slopes going on here. Okay, so you're taking the derivative. If it's easier to get, okay, you could write from here and say that v equals 25 pi over 588, if that is. You can do this as v prime equals 25 pi over 588. 3h squared times h prime. If that's easier to see, it's just the derivative of v and the derivative of h, right? But it's still the rate of change compared to time. That's what it is. Yes. Both of them is because you're the rate of change of velocity. Both of those things are dependent on time. We're getting into things where there's multiple variables going on here. Like there's not just an x and a y. There's like multiple variables going on here. Well, because the question told us that things were changing per minute or per second, right? Like the wording of these questions, because these aren't meant to be arbitrary, right? Like it says when it's, when we're going here at 2 meters cubed per hour, that's a volume per hour. That's your change. Okay, so everything's going to be. So these aren't meant to be arbitrary. They seem a little arbitrary when they're in the time point, but they're not meant to be because this is the wording of the question. Okay, now this is tricky. I'm going to do one more try like this. 0.1. Oh, of course we have part B. All right. So for part B said, oh, you want to do the first one?
Why didn't we?
Well, because somebody was suggesting this way, and this one works just as well too, right? This one works just as well. The other way should give you the same answer as well. Possibly. The only difference is that I had an h instead of an h cubed. That was the only difference. Okay. Let's keep going here, okay? We'll come back, okay? All right, letter B said, at what rate is the radius changing the top of the water tank when the depth of the water is 6 meters? All right, Benny, you're up. Can you tell me something for the second question? What do I know? Good. Excuse me, Melanie, is there anything else I know for this question? Good, so that's going to be my what? Right, buddy? No. H, thank you, H is 6. Courtney, what else do I know for this question? It says, at what rate is the radius of the top of the water changing? How do you say the radius of the water is changing? What would that be? Two heads for president one, that's great. Determined by dt. That's what we're actually looking for there in this case. Okay? All right, so we're going to use a similar thing we did the last time. Okay, using the same thing, I'm going to do h over r is 14 over 5. So I'm going to say h, the same thing. So I'm going to say the same way, r equals, yeah, 5h over 14. And h is going to be 14 r over 5, 14 So there's the easy way and the difficult way to do this. We're looking for dr by dt, right? That's what we're looking for. The neat thing is here, because our height's the same and everything else is the same, I also can say from above that dh by dt is negative 0.1386, right? So what I can do if I want to right here is I'm just solving for, so I'm going to use r equals, actually the one. I can just cheat and go h equals 14 over 5r. Okay. Can I get somebody, please, that being Nate, take the note of that if you'd be so kind. There's a thing on the right-hand side. Yeah. Now, the reason we can get away with this, in this case only, is because everything's the same as the first question except for dr by dt. Okay, so because we already know what dh by dt is at the radius, the height of 6, you don't need to solve it all out again. You could solve it all out again, you get the same thing, okay, right? And we do the opposite way. So instead of, with this way, since we have this, we can go from here. I'm going to sub my values, I'm going to get negative 0.1386 equals 14 over 5 dr by dt. Liam, can you solve for dr by dt, please? Thank you, Liam. Liam, can you solve for dr by dt, please? I got it, because this times 5 divided by 14, right? So negative, something a little smaller, 0.0495. Now, I just want to make sure about this, because there's going to be some confusion here. The only reason I could get away with this in the part B was because I already solved what dh by dt was in the first part. Okay? If this question would have been reworded saying, what's dr by dt when h equals 7? I couldn't have done it this way because I wouldn't have known dh by dt, right? Okay, because we found that in part A, all right? But since the heights were the same, I can cheat and speed up my day a little bit here. Are you okay on the logic there? Okay for that? Yeah,
so if it was 7, you have to do all of it all over again?
just like part A again, okay for that, okay? But I could cheat and speed this up tremendously this way, right? Intent test, speeding up your life. Yes, okay. I'm going to pick pause and we'll, oh my goodness. I wanted to get to more examples. I have time only for one more example, I think, here today. By the way, to Evan, I mentioned